Good morning, everyone. The session today is prompt evaluation framework. I think Catherine gonna walk us through a little bit more about the how this topic gonna unfold. But yeah, I would like to welcome on stage Catherine, the Gen AI solution lead from Google.
Just a brief introduction of myself. So my name is Catherine Wang. I'm currently in Korea, but based in Singapore. I'm the principal architect for Gen AI in the AI practice team for APAC customer. My role is to help customer, top priority customer in APAC to adopt Gen AI and build in production solution at scale. This years I've been working with many customers in APAC, and one of the repeating topic for every customer, doesn't matter if it is a senior executive or a developer or community developer who want to build or use generative AI in production. They always come back with how we can run evaluation, how we're going to measure which version of the prompt or which model can do the work better. If I change the model, how can I reevaluate? So I'm confident that if I'm moving to the new version of the model, the accuracy of my application or the accuracy of the model inferences wouldn't drop. So that's why today I really want to cover how Google Cloud is thinking of offering you or helping you to design and develop an auto or semi-auto way of doing evaluation. So this is a rough agenda for today. So I'm going to cover what and how to evaluate, the challenge, the key challenge of doing large language model evaluation, and how we are thinking as offering the evaluation services from the flagship product we have called Vertex AI. I hope everyone already familiar with Vertex AI. And then if time permits, I'm going to go into a demo or I'm going to take some questions from the audience. So what and how to evaluate large language model? Generally speaking, when we are evaluating a large language model, we need to understand what we're going to measure. That's the task. That's the performance that you want to measure on each of the use case. Use case can be generating a new marketing content, generating a new campaign email, or Q&A, answering question based on some ground truths or some knowledge base that you are providing. Then the second part is the context. How are you measuring your model performance? Measuring model performance as the academic criteria, say for example, the blue or rouge score, versus really evaluating your model output in the context of your application is completely different. In the context of your application, needs to be tied closely to your business outcome. Let's say you are adding this large language model to your application. The key driver is to increase the user interaction. So user interaction should be the key evaluation metrics. And the third part is really crafting the criteria to measure your model outputs that closely align to the business requirement. So what's the caveats between traditional machine learning evaluation versus the large language model evaluation? So for the traditional machine learning evaluation, let's take an example of regression, classification, or clustering. We have a pretty simple metrics of how we're going to do or how we're going to measure different type of machine learning models. That can be precision and recall for classification. It can be R-square or coefficient for regression, or clustering, measuring the distance, or that divergence of your model, right? But if you're taking a look at the large language model lens, it is far more complicated. So I am defining the well-known evaluation metrics from the large language model side, which is count-based metrics. That is counting how many correct word providing by the large language model comparing to your ground truth data. It can be embedding. Let's say based on the specific metrics, if you are using large language model to generating the embeddings of your text, how closely it is to your ground truth, right? And as you can see, we have so many scores in here. We also want to measure, hallucination. We want to measure the precision, the fuzzy match, the factuality of the answer. Adding all this into the picture, you have a fairly complicated metrics. So you need to understand which metrics to choose, on which task, on which context, and how to align those metrics to your business problem. So the key challenge for large language model evaluation. The first one is, of course, lack of data. Many customers jump into adopting Gen AI without really having an idea of how we're going to measure or have an idea of what good look like. So when we're using the pre-trained model, when we are using pre-trained model to perform a specific task, if you want to measure it, we need to have the adequate or existing data set to run the evaluation. That's the target we need to have. The second is lack of metric. As I mentioned, we have so many academia or numeric metrics that we have to measure the output. But in which use case you need to choose which metrics is very tricky. And the third one is the decision space is very large, right? So when we are doing the pre-trained model, when we're doing the fine-tuning, when we're doing the in-context learning, or when we are loading the adaptation layer on the fly to run the inferences, in which section are you going to measure the model performance? And which section is more important to your application? That's to be decided, right? So let's take an example, a very, very simple example. When we are evaluating an application that can automatically summarizing, let's say, a meeting record or summarize a chat history, right? So before you're ready to launch, the first thing is, how can I craft my prompt template? This is prompt engineering. Imagine that you are working with a team of 10 different prompt engineers to really iterate and nail down to the specific prompt template that perform the best for a specific model. How are you doing the prompt management? How are you comparing different prompt performance against different models? The second one is the model a good fit for my use case? Let's say you want to compare Gemini Flash version 1 to Gemini Flash version 2, or you want to compare Gemini Flash versus Gemini Pro. So which model is a good fit for my use case on this particular prompt template? And third one is how to augment the model's knowledge, right? So this will be, as I mentioned before, in-context learning, aka when you are providing few choice example or chain of thoughts inside of your prompt template. How can you augment the model knowledge in that sense? Or in terms of doing fine-tuning, you are tuning the model with a new set of knowledge. How to augment that knowledge, that data, to further align your model output. And then the third one is the tuned model. Is the tuned model a better model? Or if you want to do a distillation of the model into a smaller one, let's say, if you're training a Llama 16 billion model, and that is too big for you to deploy on your application, you want to distill it into a smaller model. Will the smaller model perform as good as the original model? So those are the things we need to consider before we even think of launching, right? So to the Gen AI evaluation services inside of Vertex AI, I'm going to cover four main services or 4 main features we are offering right now. The first one, this is better. So let's take an overview of what has been offered as part of the Vertex AI evaluation services. And at the very top, we have what model can I evaluate? So we have, as I mentioned, Google Foundation model, that is the Gemini family. And then we have open source model. That model can be accessed via the Vertex AI model garden, including Llama, including Misrel, including Quint, and other smaller models, or any proprietary foundation model. That is the model coming from Claude, Claude Sonnet 3.5, or you customize the model. That's the model that you fine-tune. That's the model that you distill. We have 4 distinct type of model that is available for you to bring into the evaluation metrics. And then what evaluation modes do I get? The first one is, of course, a synchronized evaluation. That is, you are evaluating your model as a batch service. You have the ground truth and you run one big batch of work as the pipeline service, and you are getting the result, so you can compare the result asynchronously. Or you want to have more of an interactive evaluation. Let's say when you are deploying your model and you are offering the model as an inference endpoint as part of your application, and you want to have the real-time user feedback as part of the evaluation metrics, we are also providing that to you. So what method can I use? I need to add a bit of explanation into this. So computation method means we have a well-crafted metrics. Let's say the root score, the fuzzy matching, the blue score. We already know how to calculate those in a computational way. So we have a score for blue, we have a score for rouge. So that is computational metrics or method. The iterator is more interesting. In this method, we will be using a separate large language model acting as the iterator to evaluate the original output from your fine-tuned or your trained model. The third one is, of course, asking human. So asking human to evaluate the model output in a more interactive way. So I'll skip this one. So this is by far the capability that we are offering inside of Vertex AI. This is a bit complicated. If you remember what I've been mentioned before, we do have different types of evaluation. So rouge score, F1 score, or blue score, those are all computational metrics for you to measure your model output. And those will be suitable for tasks like classification, summarization, text generation, or Q&A. You can use those metrics as the auto metrics when you are running the evaluation pipeline inside of Vertex AI. And we have auto SNS, which is a much scaled up way of running model comparison for different models. The full name is auto side by side, meaning that when you are measuring the output from 2 models, you have a side by side compare of 2 batch output. And then we are also providing the product integration. If you are using open source model or proprietary model from Model Garden, you have the API, and we are also providing, generic API if you want to run in production evaluation or inference evaluation, or you simply want to run some experiments, right? So this already explained. So first of all, the automatic metrics. Automatic metrics are I would say quite mature at the moment. Those score has been widely used in the community to measure the performance of each model. When you are seeing, Gemini is taking the leaderboard of X, Y, and Z, that is primarily using those computational metrics. Those metrics are fast and efficient, right? And for specific tasks like summarization, Q&A, you can just use these metrics out of the box to quickly evaluate your model, and it is low cost. When you are evaluating your model using automatic metrics, you need to prepare the ground truth. That is the input prompt and desired output prompt. Many customers doesn't have this. So if you don't have this, you probably wouldn't be getting a very good result in running auto metrics. The benchmark evaluation metrics is one way to say how good my model is in the academic sense. However, there are caveats of bringing this benchmark to the real world, right? So the second type of evaluation is the auto rater. So the first is auto metrics. So the auto metrics is using mathematical formulation and techniques to evaluate the goodness of the large language model responses. So this is just using one metrics. And the second one is using auto point-wise metrics. So the point-wise metrics is measuring the metrics that you define from one model to the other as a point-wise ways of viewing it. The auto SNS, as I mentioned, it is measuring like 2 large language model response at a batch. Those are some of the terminology or taxonomy when we are talking about auto point-wise evaluation. These include coherence, fluence, safety, groundedness, fulfillment, summarization, quality. As the name indicates, those metrics can be used on different use cases. And again, those metrics is already being provided. It's a default metrics that you can choose from when you are running the auto point-wise evaluation, right? This is a continuous of the auto point-wise evaluation. I'll just give you one example. So the safety evaluation, for example, for this particular evaluation, you don't necessarily need to have the ground truth or the summarization verbosity. So this one, we don't need to have the ground truth. There is a documentation to show you which auto point-wise evaluation need to have ground truth, which one doesn't need to have. So just bear in mind, you need to provide the guidance to the evaluation pipeline to say which method I'm using and what is my target, right? And then come to the auto side-by-side. This is just simply one example of summarization task, right? You need to define the prediction, the context, and then the references. Of course, the references is optional, right? So you define the prediction, which is the summarization that you are generating, the context, which is the context that you wish to summarize. You can give the reference, which is the ground truth, or you don't need to give the reference, and we will be evaluating the summarization based on the 4 criteria. And then you will be able to compare the score format of Model A and Model B. I have a notebook to show you the prompt engineering, but I'll go through the process first. So first of all, the first step is, of course, for the prompt engineering, I want to figure out which prompt works best in my use case. And when we're doing the prompt engineering, we are actually using this part. So we are using a Google Foundation model, and we're doing it in an interactive way, which is when I'm prompting, I'm getting the result, I'm getting the computational output or the iterator output. I'll quickly jump into my notebook so you can see it in real life. So inside of Vertex AI, we have a service under Vertex AI Studio as prompt management. So this is the out-of-the-box, in-console ways of comparing the prompt, right? If you click the prompt management, those are all the prompt that has been written by different team member, and it's tracking the prompt itself and the type of the prompt and some notes. So you can add notes when you are generating that particular prompt. So let's say if you want to have a look at this particular prompt, you can go inside and the prompt will be loading with the configuration of the model, right? So it's all loaded in here. And you can see the previous response of that particular prompt. You can, add your own notes in here when you are running this evaluation. You can see the history, who has run this before, and what's the result. Sorry, didn't show. So who has run this before? What's the performance? And you can decide, what look better in the real sense. Of course, when you run your version, you can add your notes. Let's say for this particular run, I change the temperature a bit, and I can add my notes. The behavior is different, something like that, right? So let's say when I want to compare two types of prompt. So for this case, I'll say I want to compare this version and that version, right? I click those two, and I can say compare prompt. Sorry, my bad. Compare prompt. Bring to this new page, and then I can say compare saved prompt. Loading the prompt name. So I need to choose. So just for the demo purpose, I'll just choose some random one. Okay, let's compare those three, right? When I say click, it's going to take some time. So it's running the prompt on the fly with the model configuration and getting you the result. This, I would say, is a very good way if you want to do a quick experiment, right? And you can see the output. Of course, you can add the ground truth. It will give you, if you have the ground truth, of course, you will have more metrics. But this is again the way that you can compare the prompt. If you want to do it in a more systematic way in a notebook, you can run the evaluation notebook by clicking this. So if I click this one, I'll go into a separate page. So the exact same look and feel of comparing different prompts will be available for you to test in a Google Code Lab. So when you open up this notebook, this is already set up for you to run. You can run it in Code Lab. You can run it in Google Vertex AI Workbench, which is in here. You just run it, follow this instruction, setting up your configuration, your model, specifying the location, the project ID. And then in here, you simply defining the model. So you can choose different model, just give the model name, and then define the metrics. So those metrics will be the metrics that I mentioned before, the pairwise metrics. And then you're defining your prompt template. So you can skip the system prompt if you don't have the system prompt, and then just run the model as it is. When you run it, you will have the result. So I'll give you a more concrete example. Let me just open this up. So this is the example that I'm using for one of the customer. Yep. Okay. So the same thing. This is the helper function, which is not critical. So the same thing. You set up your project. and import the library, import the helper function, and then you sort of like want to, I am assuming you have the prompt template. So this is my prompt template. So you specify the prompt template. That is the prompt with the parameter as the placeholder you want to fit in each of the prompt. So this is one way of setting up the prompt template, the system instruction, which you can specify in here, the questions that you want to ask, which you can specify in here, and the requirement, which is the context. This is Q&A, so I'm putting the question or the in-context knowledge in here. Set up the prompt template, defining the model output, specifying the model that you want to choose. In here, I'm choosing Gemini Pro, but you can choose Gemini Flash. Then generating the output. When you are seeing the output, you will be seeing, the compiled model response. In here, have a quick review whether or not it is aligned to your expectation. And you can compare, optimize the prompt templates for prompt engineering. In here, I can add multiple instruction, multiple contexts, let's say 1, 2, 3, 4, 5 different contexts with the same task, which is summarizing the below article. And then I'm giving the reference. For each of the contexts I'm providing, I have a reference of what good look like. And then I'm running it as the batch. So again, building the prompt template, taking the example from here, and then run it. When I'm running the evaluation pipeline for each of the prompt templates, I define more metrics. So I hope you remember these metrics, right? So some of the metrics are computational metrics. Some of the metrics are auto-rater metrics. And with the auto-rater metrics with the point-wise capability. And then I set up the model configuration, temperature setup to be 0.3, and I'm running the evaluation as a batch service. So as you can see, the model is running, blah, blah, blah. And as an output, I have a summarization of all the metrics that have been defined above in here and output in a table, right? It's a bit messy to see, but if you want to see it in a more granular way, you just export this Excel or export it in BigQuery, and you can run some analysis in this, right? So version 1, 2, 3, 4, 5. Okay. And this is one way of seeing this result, right? So you can also print out specific metrics output, right? So for the summarization verbosity, which is how rich of the verb that has been used in the summarization. If you print this one out, it will provide you with the context, the reference, the complete prompt, and the response. So what we are comparing is the reference against the response. And then the model is able to give you the model as the auto-rater, going to give you the explanation of why it's giving the score of this summarization between reference and response, right? So have a better look at this one. I think we have. I can share a example link for this particular notebook, so you can run it by yourself. Another way is to visualize the result, the score, in your plot, right? So again, very simple plot. So I'm plotting the fluency, the coherence, the summarization quality, and the summarization helpfulness into a chart. So you can see the prompt templates 0, 1, 2, how they're comparing to each other, right? For the most of the time, you cannot have one model that is good at everything. So you need to choose what means more importance to you. If you think the summarization helpfulness is the most critical metrics you want to track, then you probably end up choosing prompt 2. Whereas if the coherence is more important, you choose the prompt one, right? Again, this is just different ways of viewing the output. Of course, you can build your own plot. Nothing stopping you. It's just from Plotly. And you can also display the summarization in the table format, right? So this is the example for the prompt template. So the model comparison is comparing in a similar sense, not only on the prompt, but I want to shift from model 1 versus model 2. The same exact step. We define the matrix, we define the prompt template, and then we specify which model I want to run. And then the output of the model comparison will be able to tell you how you are comparing this specific prompt from model version 1 versus model version 2. Again, those metrics you're seeing in here is defined by you, right? And then you can see how model compared against each of the evaluation metrics. Because I'm comparing, I think in this particular use case, Gemini Flash 0.1 versus Gemini Flash 0.5. So you can see a distinct differences between two models in different evaluation metrics. So the third one is evaluating at scale. This is an interesting one where we are using more of like auto SNS type of evaluation. So when we are running the model and SNS, there is an example notebook that I can share with you after this session for you to run. This is the result. So the caveats of running individual comparison of model and prompt versus this particular one is this is more of a batch review. So you are comparing two models and you are defining the specific metrics you want to measure and the specific target, let's say the summarization and the specific metrics that you want to measure. And then the model, the auto side-by-side pipeline can give you a win rate of in which sense, which model is the winner in this task, right? So again, this is a visualization inside of Vertex AI. And you can, of course, open data into Google Sheets, or you can download the data and creating your own plot. The raw data is all there, and it's up to you how you want to use this information to make your decision.